John from Infineon, and he's going to talk to us a little bit about a super high-powered USB-C charger. John, tell us about what you got there.
Perfect, yeah, so thank you very much. So this is a 240 watt USB charger. It's got universal input, so it's got 90 to 265 volt input, and we've got two individual and independent ports. So that means that each one of the two ports goes from 5 volt up to 48 volts, and these are independent from each other, so we can get whatever we want in each one of the two ports.
Interesting. What's the Infineon part in there?
So the Infineon parts here, we are showing a vast number of components. Mostly we feature our gallium nitride technology. We are featuring it both for 600 volts and also for 100 volts. So we've got 600 volt integrated half bridges that also include the gate drivers inside. And we've also got 100 volt devices, discretes, 2.5 milliohm typical. So we have also some cool MOS silicon superjunction devices because we've got a totem pole PFC rectifier with two interleaf bridge legs. And why we use gallium nitride is because we push the frequency to the extreme level. So we've got the PFC with two interleaf bridge legs at 400 kilohertz each, giving us 800 kilohertz for the EMI filter. Then we've got an LLC operating in resonant frequency in 425 kilohertz, also with our high voltage GaN in the primary and the low voltage GaN, or the medium voltage GaN, 100 volt devices in the secondary. And then we've got the two buck converters, each one operating from 140 up to 400 kilohertz, also with our medium voltage GaN.
Now, is this a reference design that anybody can get hold of, or what's the status?
So this is a very advanced engineering design. We are working towards making it a reference design, but this is still very out of the oven prototype. So it's really, we've been working on it just a week before coming to APEC, taking the last measurements. So it's still in that phase.
I see.
But it's already open, and we are also polishing a paper in 2 months' time with the full technical details of this board, and the technical details are also open to every visitor who is interested.
I see. Well, with that kind of power output, what kind of applications would you see for it?
So that's a very good question. This is a charger that works worldwide, and it also works for all the applications you want. So you can have a high power laptop with your cell phone, but also, for example, you can use your e-bike. So you have to go to the mountain with your e-bike, you could take this. In the future, you'll be able to charge your e-bike with the same power as with your current brick charging. So this is really, the USB power delivery standard is going to be the future for everything. So you can, anything that's up to 240 watts, essentially battery powered, you'll be able to power from this. So we're ranging from cell phones up to e-bikes, anything you want.
I see. So if you had to get 240 watts out of a conventional silicon charger, you're still talking about a brick rather than that thing, right?
Correct. That's the, yeah, exactly. If you want to do it with silicon, so here we switched 400 kilohertz with silicon, you'd be ballpark in order of magnitude slower. So that means that your, again, ballpark, your magnetics and passives would be an order of magnitude larger. Not really, it doesn't scale linearly, but we're still talking a factor 4 to 5 smaller power densities, especially in taking it to the extreme as we've done it here. Yeah?
Cool. Well, John, that's very interesting. Where should our viewers go for more information if they want to get it?
So for more information, they should go to our Infineon webpage, definitely. We're also publishing a paper in the PCIM conference in Nuremberg in May 2022. And they can also contact our local sales team or marketing team, and they'll redirect those people who are interested to the right people.
Great. Well, thank you, John.
Thank you very much.
Cool stuff.
Thank you very much.